Okay, continuing where we left off last time, we have to come up with a box and whisker plot now. So the box and whisker plot is basically just a visual representation of all of the most of the statistics that you guys were learning about before. So the minimum value, the maximum value, Q1, Q2, and Q3. Okay, so first of all, let's start by identifying what's going on here. Q2 we know is the median. So obviously that's going to play a role. And then Q1 and Q3 are the quartiles, quartile 1 and quartile 3. Those are going to form the left. Quartile 1 forms the left, and quartile 3 forms the right sides of the box. The median forms this bar that we were going to put in the middle in the box somewhere. It doesn't necessarily have to go in the middle. This just depends on where the median falls. Okay, the Q2 does not have to be in the middle. Then all we're going to do is connect the top and the bottoms of those endpoints of the bars that we drew, all right? And that makes the box. Now, for the whiskers, all you have to do is figure out what the minimum value is, and that will be a point, and then figure out the maximum value is, and that will be a point, and then you draw the connection segment over, and that makes the whiskers. That's it. It's a super easy thing to do, but the tough thing is the number line. Okay, so the first thing you want to do before you draw a box and whisker plot is draw a number line. And the number line just needs to have the scale on it that's going to match up best with the minimum and maximum values for the data that you're looking at. Now, down here, we're asked to, it says the graphing calculator will generate all the statistics we've done. Yes, we know that already. And it will do a box and whisker plot also, but I want to show you how to do it by hand first, and then I'll show you how to do it on the calculator. It's really easy. Actually, it's easy both ways. So anyway, generate a box and whisker plot for the St. Petersburg data and another for the Dauphin Island data. Okay, so what we're going to do is we're going to go back and look at that data. All right, and we're going to decide what the smallest number is between the two, St. Petersburg and Dauphin, and we're going to decide what the largest value is between the two so that we can graph both box and whisker plots at the same time with the same number line. And that way we'll be able to compare the two visually and be able to like answer questions or decide which place is better or whatever it is we're trying to do. Okay, so let's look back at the data for St. Petersburg and again for Dauphin. They're all on the previous page. So let's see if we can just copy them over to this page so that we don't have to keep going back and forth. All right, so first of all, St. Petersburg. We had, there's some statistics that we calculated that we don't really need here. We just need Q1, the median, or Q2, Q3, and then the minimum value and the maximum value. And really, all of those are sitting there on our calculator, okay? And then we're going to do the same thing for Dauphin Island. So, same thing. Quartile 1, quartile 2, quartile 3, minimum and maximum value. So if I look at my calculator, we see in column A, STP for St. Petersburg, and then column D, Dauphin Island. So I have all those statistics calculated out. So if we come up here, we have, let's see, the minimum is 62, and the maximum, why does it keep doing that? So the minimum for St. Petersburg is 62, and quartile 1 is 66, the median is 76, quartile 3 is 84, and the maximum is 86. All right, so we kind of have a range of ideas, range of values that we have to fall into. If I look at Dauphin Island, the max is 84. Quartile 3, median, quartile 1, and the minimum is 51. So what we're going to do is pick the smallest of the two. Between 62 and 51, the smallest is 51. So when I draw my number line, I'm going to put on the far left the easiest number that continues to be smaller than the smallest number, which would be 50. And then my maximum values are 86 and 84. So I'll continue and find the next largest easy number, and that would be 90. So I'm going to put 90 on this end. Okay, and this is a number line, so I'm going to put arrows on the ends. Now all we have to do is fill in kind of an easy scale for the numbers in between. We're going from 50 to 90. It seems like a scale of tens would be just fine. So 50, I need 60, 70, 80, and then the 90 is already there. So 70 is going to be right dead center, 60, and then 80. Okay? Don't make it overcomplicated. This is super easy to draw a number line like that. And if you need to, you can put like little tick marks in between for 55, 65, 75, and 85, and it's understood what those are. You don't even need to label them. Okay, so now let's go back to the calculator with all those values and see if we can enter in or create our box and whisker plot for, I keep wanting to say Stone Temple Pilots, but that's not right. It's St. Petersburg. So we have a minimum value of 62. What we're going to do, though, is first draw our box. So quartile 1 is 66. So we go to about where 66 is, and we draw our first bar. And let me label the top St. Petersburg. I'm putting St. Pete just so I don't keep calling it Stone Temple Pilots. Okay, so we have quartile 1 is 66. And now we want to label that 66. Quartile 3 is 84, so we're going to come over to the 84, come up and draw a bar, and I'm going to label that 84. And then the median is 76, so I'm going to go over to where I think 76 is with my number line, and I'm going to label that one 76. Okay? And then all you do is you draw the top and bottom of this rectangle. Now you have your box. So then it's just a matter of coming up with the whiskers. So we know that the minimum value is at 62, so I'm going to mark 62, and I'm going to label that, draw the whisker over to the box. Same thing with the maximum value, 86. So I go to where I think 86 is, I label it 86, and I draw the whisker over to it. And that's your box and whisker plot for St. Petersburg. So now we're going to do the same thing for Dauphin Island. So I'm going to come over to my calculator and move over. Same stuff, right? So we have minimum value is 51, but we're going to do the box first. So we're going to go quartile 1 starts at 58. So I draw about where I think 58 is, and I can label that 58. Quartile 3 is at, looks like 81. So I'm going to come over to where I think 81 is and draw it and label it 81. And then the median is at 71. So there we go, 71, label it. Now draw the box. Okay, so now we just need the minimum value, which is 51. So I go to where 51 is, label it, and draw the whisker over. And then we have a maximum value of 84. So maximum value here is 84. Draw the whisker over, label it, and you're done. So now you have your two box and whisker plots. This one on the bottom is Dauphin Island. Okay? So that's how you do that. Now, let me get rid of the calculator here because I'm going to ask you potentially questions. The whole point of doing a box and whisker plot is to be able to visualize what's going on with the data that you're looking at. And when you do two together on the same number line, then you can compare them. So let's compare St. Petersburg and Dauphin, right? Which one looks better? Like if I was to try to go on vacation somewhere, and really the only thing that mattered to me was water temperature at this place that I wanted to go on vacation, which one would I choose? No matter what time of year. The answer, hopefully, you're thinking would be St. Petersburg because obviously warmer water is more pleasant to be in, right? And overall, the St. Petersburg range of stuff is all occurring here, while Dauphin is all occurring here. And there is just a larger spread of data. Not only that, but if you look at the box, most of the data is occurring inside the box, okay? Most of the data is occurring inside the box. So most of the data for St. Petersburg shows us that we have a generally warmer temperature than on Dauphin Island. So if I was interested in being in the water to go on vacation, I would probably more likely choose St. Petersburg because at any time of year the water is going to be definitely warmer, okay? It's more consistently kind of like not the same temperature, but it just doesn't vary as much, all right? That word variability, spread of data, is important here. So that's what a box and whisker plot will do for you. It helps you visualize quickly what's going on, and you can make comparisons nicely. And the last thing that we need to talk about in this section is percentiles. So if you've ever taken a standardized test, which all of you probably have, and gotten results in the mail, they probably gave you, or maybe it was emailed to you or something, but they probably gave you some sort of a readout that said, in this topic or this subject, you were in the 84th percentile, or maybe it was the 99th percentile, or the 52nd percentile of people who took the test. So what does that mean? Well, that's what we're going to learn about here. So a percentile is a number from 1 to 100 that you associate with a value from a data set. So basically, in a nutshell, what this means is it's the percent of data that is less than or equal to that value. All right. So on your standardized test results, when you get them, and it says that you're in the 73rd percentile, it means that you scored better on your test than 73% of the people who took the test. So like if it was the ACT, then you would have scored better on that particular test than 73% of the rest of the country who took the test that year. Okay, so that's what that means. So now to calculate a percentile, the first thing we're going to do is order the data. All right, put everything in order from least to greatest. That's the best way to do it. Then count the number of data entries. Okay, now then multiply the number of data entries that you have by the percentile that you're looking for. And that number that you get as a result will give you the term number for the value at that percentile. Okay, it does not give you the percentile, it gives you the term number for the value at that percentile. So here's an example to try to make sense of what just happened. So there's an ordered list of midterm test scores for a Spanish class. Okay, so everybody in the class took this test, and here are the scores that they got. What value is at the 65th percentile is the question. So first thing you're going to do is you're going to order the data. Well, it already is. It's going in order from left to right and then from top to bottom. So the lowest score is 51 and the highest score is 100. Okay, so how many pieces of data do we have here? Well, there's 1, 2, 3, 4, 5, 6, 7 across and 2 full rows of that. So that's 14. And then 15, 16, 17, 18, 19, 20. So there's 20 pieces of data here, okay? So first, order the data, we did. Then count the number of data entries, we did. There's 20 pieces of data. Now, multiply the number by the percentile desired. So we're looking for the 65th percentile, sorry. So what we're going to do is we're going to say, well, 65th percentile is like 65%. And 65% as a decimal is 0.65. Okay, so the percent times the number of data entries, which was 20. When you do that on your calculator, you get 13. So that means that in our ordered list of data, this stuff here, the 13th one in order from least to greatest will give you the 65th percentile. So you just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The 13th number in our list of data, in the ordered list of data, was 82, which means the 65th percentile, not percent, 65th percentile is a score of 82. And that's it, okay? If you wanted the 90th percentile, you would come back up here and multiply your 20 by 0.9 and get a result, okay? So 20 times 0.9 would be 18. So then we're looking at the 18th term, and that would be that guy right there. So the 90th percentile is that term, which was 98. So a score of 98 would put you in the 90th percentile. 90% of the people who took the test scored lower than 98. 10% of the people who took the test scored higher than 98. And on the original problem, 65th percentile means 65% of the students who took the test scored lower than 82. The remaining 35% scored 82 or higher. Okay? That's how you do percentile. And that's it for the section.